In this video, we'll discuss the stoichiometric calculations in solutions. When we discussed reactions in solid state, we were correlating the amounts in terms of grams. But in solution, the amounts of reactants is measured in terms of concentration. So concentration is basically the amount of the solute in a given quantity of solvent. And that can be expressed as a ratio in grams per liter. But the most common expression for concentration is molarity. So molarity is the number of moles per liter of solution. So it's basically dividing the number of moles of your solute or your substance by the liters of solution. If we would like to prepare 250 mils of potassium dichromate solution with this specific concentration here, how much grams do we need? From the definition of molarity, molarity equals number of moles by volume of solution in liter. So we have a relationship that correlates molarity to number of moles of the solute and volume in liter. So if we have two of these, we can simply calculate the third one. So if we take volume of the solution is 250 milliliter, multiply it times the conversion factor from liter to milliliter. 1 liter is 1,000 milliliter. Then we multiply it times molarity as a conversion factor now, which is 2.16 mole of the substance per 1 liter. Now we have the number of moles of dichromate needed, and all what we need is convert moles to grams using the molar mass times the molar mass. 1 mole of the substance weighs 294.2 grams. That's going to give us the amount needed in grams, which is going to be 159 grams of potassium dichromate. So in order to prepare a solution of this substance with this concentration here with 250 mil, what we will do is take 159 grams of the substance, put it in a volumetric flask with a total volume of 250 mil, and start adding water to dissolve the substance, dissolve it, and then fill the whole flask up to the mark with water to make the total volume 250 milliliter as required. This solution here is going to have the concentration of 2.16 molar of the substance. A special procedure that is commonly used in preparing solutions is dilution. So you start by preparing a stock solution with high concentration, and then you dilute it to less concentration solutions as needed. And in this case, you can calculate the expected concentration of the diluted solution based on the amount of water you add. Because when you do this, after dilution, the number of moles of your substance, your solute, is not going to change. What will change is just the amount of water, which is not going to affect how much solute you have in that solution. So based on this fact, number of moles before dilution is going to equal the number of moles of the solute after dilution. And from the definition of molarity, number of moles equals the molarity times volume. So molarity times volume before dilution has to equal molarity times volume after dilution. And you can use this formula to calculate the expected concentration after dilution for any solution. So for example, if you start from a stock solution of sulfuric acid with this molarity right here, and you want to end up with 500 mils of that molarity, how many mils of the initial solution you need to start with? Volume of the dilute solution is going to be 500 mils. We need to convert them to liters, so we'll multiply times the conversion factor. 1 liter is 1,000 milliliter, and then we multiply times the molarity. which is 1.75 mole per liter. That's going to give us the total number of moles in your solution. And then you use the initial molarity to calculate the required volume. So we'll take this number of moles, multiply it times 6.81 mole per 1 liter, which is the inverse of this value for molarity. And that's going to give us the volume in liters, but we're asked to express the volume in milliliters, so we will have to convert it again to milliliters. So it's going to be 1 liter is 1,000 milliliter. 101.6 milliliter. The second procedure to solve this question is just simply using the formula that M initial V initial equals M final V final. So from this, you can rearrange because you have the initial molarity, you have the final molarity, the final volume. You are solving for initial volume, so the initial volume should equal final molarity divided by initial molarity times the final volume. We'll just substitute the numbers into this formula to calculate the initial volume. So it's going to be 1.75 molar, which is the final molarity, divided by 8.61 molar, the initial molarity, times the final volume, which is 500 milliliter. And that should effectively give you the same answer.